Okay, welcome calculus students. I'm going to give you the notes for 4.5, the fundamental theorem of calculus. And we're going to talk about this, the fundamental theorem of calculus, and we're going to evaluate integrals versus finding the area under the curve, which we've been doing, but I wanted to show you how this theorem worked. I want you to remember that if a function f of x is continuous on an interval a to b, and little f of x equals the derivative. So again, the large f of x is your original function. The small f of x is the first derivative, if you will. Okay? So that's what they're saying here. Little f of x equals the large f of x, f prime of x. Okay? So here is the theorem in a nutshell, that if I have an integral from a to b of f of x dx, which I know you guys can put this in your calculator, it's the same as taking the original function. Okay, so this is my original function. Take the end minus the beginning. So here we always go from a to b of this. Well, when you take this, you're going to do f of b first minus f of a. So this is your original function, end minus the beginning. So again, it's stated here. If f is continuous on every point and f is an antiderivative of f, then this is the same as taking the original function and taking the end minus the beginning. So we're going to have to do some antiderivatives. Now, the cool thing with every one of these guys is that you can actually put all of these in your calculator when you're done and check them. So for example, you could put this in your calculator and get the answer, and you would get 21. Okay? So the integral from 2 to 5 of 2x dx is 21. But this is what I want to show you to show for work. First of all, I want you to do the antiderivative. So when I have you do the antiderivative, I'm going to have you do a bracket. And the antiderivative of 2x, we add 1 to the power and then divide it by that, is actually x squared. And we're going to evaluate it. This is from 2 to 5, so you write the 2 to 5 here. Now, the one thing different is when you do your original function, because this is really your little f of x, if you will. This is your capital F of x, if you will. So we have to do f of 5 minus f of 2. So when I do f of 5, it's going to be 5, okay, squared, minus f of 2, which is going to be 2 squared. And 5 squared minus 2 squared is the 21. So basically, you can put this in your calculator and find the answer, but this is the algebra that you're going to show by using the first fundamental theorem of calculus. You're going to show me how it works doing it that way. So you're basically showing me the algebra using antiderivatives. Okay? So I have the integral from 0 to pi of cosine x dx. I want you to tell me what the answer is using the fundamental theorem of calculus. So we're going to do the antiderivative of cosine, which is sine. We'll put that in brackets. We're evaluating it from 0 to pi. So since that's my original function, I'm going to be sine of pi, the end, minus the beginning. Sine is 0. And when I do the sine of pi, okay, is 0 minus the sine of 0, which is 0. 0 minus 0 equals 0. Okay? Example number 3. The integral from 0 to 1 of dx over the radical 1 minus x squared. If you look on your antiderivative card, you see that this is the antiderivative of inverse sine. We're evaluating it from 0 to 1/2. So we're saying inverse sine of 1/2, the end, minus the inverse sine of the beginning, or 0. And I know the inverse sine of a half is 30 degrees, or pi over 6, minus the inverse sine of 0, which we just saw up here, is 0. So my answer is pi over 6. And again, you can put this right in your calculator the way it is, and you're going to get the decimal equivalent of this. You can like check all your answers when you do this. You just need to show the work. Okay, so I'm going to write this in check with your calculator. Right? Example number 4. So I have the integral of 3/2 radical x minus 2 over x dx. So this is basically in two parts, but let's do the let's set it up first so it looks a little nicer before we do the antiderivative. So I have the integral from 1 to 4. So I'm going to write that as 3/2 x to the 1/2 minus 2 over x dx. Okay? If we do the antiderivative of that, so I do my brackets, the antiderivative of this, add 1 to this, so it's going to be x to the 3/2 multiplied by 2/3, so it goes away, so I have x to the 3/2 minus, and this, if you were to say, oh, that's x to the -1 and try to do the antiderivative, it's not power, it's natural log, so it's 2 natural log of x, and we're going to evaluate it from 1 to 4. Okay. So when you show this, I have to do the end, so I'm going to put the 4 in first, minus, then I put everything in with 1. So I'm going to do 4 to the 3/2 minus 2 ln 4, minus, then I put the 1 in, 1 to the 3/2, sorry, my pen's not working, 1 to 3/2 minus 2 ln 1. Okay? So when I do that, I have 8 minus 2 ln 4, so this is 8 right here, minus 2 ln 4, okay? Just wanted to show you where I got the 8 from. Then I have minus 1, because 1 to the 3/2 is 1, and then plus 2 ln 1. Well, ln 1 is 0, so plus 2 times 0 is going to be 0. So this all comes out to be 7 minus 2 ln 4. And again, you can do the decimal equivalent by putting that in your calculator to see exactly where that came from. Okay, so now we're going to find the definite integral of f of x over this interval 0 to 2 pi, and then find the area between the graph and the x-axis. Okay, so this is in two pieces, and remember what I told you. If I said find the integral, you actually can just put it in your calculator. You're evaluating an integral, and remember, area is always positive, but your calculator will make this negative and subtract it. So yes, you can put it in your calculator, but we're going to do the fundamental theorem of calculus. So we're going to do where you're actually evaluating the integral. Okay, that's the first piece of it. So when I do that, I have the integral from 0 to 2 pi of sine x dx. So that's what we're evaluating. Okay, if you put that right in your calculator, you're going to get a 0, because this area negates this area and they cancel each other, you get a 0. Now let's do this with the first fundamental theorem of calculus to see how that works. So now, when I do the antiderivative of sine, it's negative cosine of x. We're evaluating it from 0 to 2 pi. And how we actually do that is we're going to do negative cosine of 2 pi, right, minus, okay, the negative cosine is 0, so it turns positive. And see what that works to. Negative inverse, so cosine of 2 pi is 1, so this is going to be negative 1, and the cosine of 0 is 1, so you end up getting 0. So you've seen how they match. Okay, this done in the calculator. This is with the first fundamental theorem of calculus, and you see you should have the same answer. Now the B part, we actually want to find the area. Okay, area is never negative, so we have to make allowances and see where it breaks here at pi. So we're going to break it up here so that we can see. So I basically want to go from 0 to pi of sine x dx, and I want to subtract, because I know this will be negative, from pi to 2 pi of sine x dx. Okay, so that it will show the entire area. So when I put that in my calculator just the way it is, you end up getting, the first part is 2 minus a negative 2 for the area under the curve, so the whole thing comes out to be a positive 4. So the actual area is 4, even though the integral is 0, because they canceled each other out. Okay. Now let's do the first fundamental theorem of calculus to make sure we still get a 4. So again, the antiderivative of sine is negative cosine of x. And we're evaluating it first from 0 to pi. And then we're going to subtract the same thing. We're just now evaluating it from pi to 2 pi. All right? So I have negative cosine of pi plus the cosine of 0, which is what we did up here, minus negative cosine of 2 pi because I go end to beginning, okay, plus the cosine of pi, and I end up getting a 1 plus 1 minus a negative 1 minus 1. So I have a 2 minus a negative 2, so the whole thing does come out to be 4. Okay? Now let's find the area of this region between. So they said find the area, not integral, so we have to see where it breaks, and it breaks here at 0. Okay? So we're going to evaluate this function, the integral, from negative 1 to 0 of x cubed minus x squared minus 2x dx. And then we're going to subtract the integral from 0 to 2 of x cubed minus x squared minus 2x dx. And when you do that and put it in your calculator, you're going to get 3.08. So we negated this because we know this is negative, and you want to add them together to find the area. They didn't ask us to evaluate it. So we're going to use the fundamental theorem of calculus to see if we get the same answer. Okay, so we're going to use the fundamental theorem. So I'm going to set it up, and I'm going to do it in pieces. So if I do the antiderivative of x cubed, I get x to the 4th over 4 minus x cubed over 3, there's my other antiderivative, minus x squared, and we're going to evaluate that from negative 1 to 0. And when you go through and do all the work with that and plug it all in, you're going to show that, and we're going to subtract x to the 4th over 4 minus x cubed over 3 minus x squared, and we're going to evaluate that from 0 to 2. Now when I say evaluate, you're going to do end minus beginning. So we're going to put all zeros in here first. So you're going to have a 0 minus a 0 minus a 0. Alright, so you have 0. Then you can do minus, and then you're going to put a negative 1 for each of these. Okay, plug it all in. When you're done doing that, you should get for this first piece 5/12. Okay, for this piece we're going to plug a 2 in first for everything. So you're going to have 2 to the 4th over 4 minus 2 cubed. Alright, so you're going to get a number. And then you're going to subtract the 0. So you're going to have something minus 0. So I'm just putting parentheses here so that you can see. So you need to fill this in. Minus 0. And remember, you're negating this, so it's going to switch the sign for this. When you do, you should get 8/3. And when you add those up, you get 37 over 12, which really is what that is. So make sure that you fill these in. Just because I didn't do that, you can show the work for those. Okay. After this, you have some integration review. So please, I'm going to give you an assignment to work on for what we practiced for the first fundamental theorem of calculus, and then I want you to go and to work on your integration review along with your book work. And I know there's a couple labs. See you when I get back.